Hello, and welcome back to the Science Center Animal Room in Ithaca, New York. My name is Colin. I'm the curator of live exhibits, and we're going to do another tour around the animal room. Thanks for tuning in today. Right now we're looking at our reef exhibit. As I've mentioned on some past tours, this is my favorite exhibit in the animal room. I love all our animals, but these guys are extra special. Reefs are such a unique, special, and valuable ecosystem to our planet. They're barrier reefs that protect many islands. The most famous one, of course, is the Great Barrier Reef in Australia. It's the largest reef. There's also a very large barrier reef in Central America and the Caribbean. And there's barrier reefs all over the place. And barrier reefs are really special because they help buffer storms as they come toward shore. The reefs will act sort of as a wave break and help slow down surges and waves as they come into lands and help protect things. So they're quite valuable to us living on land. But then there's such a rich ecosystem as well. There's so many creatures that depend on reefs. As you can see here, we have all the corals that grow in the tank, but then there's lots of fish too that swim around reefs and make them their home. They use them for protection. They find food in them. They really are special ecosystems. I'm going to try to zoom you all in and start talking about a few of the particular animals we have in here. Check my cords out first. Nope, I'm already tied up. There we go. Grab this camera. Try not to make you all too dizzy. Still working with mostly one hand. Hopefully that'll change somewhat today. So corals are a really cool animal because they are indeed an animal. So all of these things in here, this frog spawn, and these mushroom corals, and that green one there, that's a Sama coral, a cat's paw coral. And there's a big acropora head. Back here we've got the ceratophora. This is a bacillophora. So many different types of corals. We've got the soft Kenyan tree corals over here. All of these different corals, they are animals, but they've evolved a really cool system where they have algae in their flesh. It's called zooxanthellae, and somehow, long ago, the predecessors to corals somehow figured out how to sort of engulf algae and incorporate it right into their flesh. And so for corals, most corals, it changes based on species and probably location in the reef where they're living. But most species of corals get most of their food from the sunlight that shines on their skin. The light shines on the algae, and the algae makes sugars, energy for the corals. Here we've got a cabbage coral that hides out down here. This one's starting to get shaded, so it's starting to stretch out a little bit. I'll have to do some pruning or some repositioning soon to make sure that one keeps getting its light. But almost all of the corals in this tank get the vast majority of their energy to grow from the algae in their flesh. And then another cool thing, I said most of their energy. So I'll get you focused here. Looks like it's a little too bright for us to see that one. This is a turbinaria here. I had a little frag of monopora fall into that, so that's another thing I'll have to grab in just a little bit, get that out of there so they don't sting each other. The other way corals get their energy is that they have little polyps, they're called, little mouths with tentacles around them, and they'll stretch those up into the water column, and as little bits of particulate float by, sometimes it's animals, sometimes it's pieces of animals, sometimes it's algae, all sorts of little things floating by, detritus. They'll catch that stuff with their tentacles and pull it into their mouths and eat it up. And so many corals, while they may get most of their energy from the sunlight, they will also get energy from the food they can catch. These mushroom corals here are a really good way to see a polyp. Each mushroom coral is its own individual polyp. It's a big round disc, and in the center there of each one is a mouth. And so that's sort of a large example of a polyp. We go over to the frog spawn here, and these guys, all of these long tentacles here are actually the tentacles around their mouths. They're so well extended at this point that I don't think I'll be able to find a mouth to show you. Maybe if I look. Oh, I might be able to get one over here. Oh no, I'm getting too much reflection. Well, so inside of these tentacles, there are a number of mouths that make up their polyps. And then some corals, like this cat's paw, here, this Samacora, it has tiny polyps. So I can get as close as we can to that one, and you'll never be able to see those polyps. You practically need a magnifying glass to be able to see the polyps on that one. And we can come over here to the Ceratopora, this, maybe a little too much light there too. This one has small polyps, but these are small enough that you can see. Perhaps you can make out little dots along the branches there, and those little dots are the polyps. This Bacillophora, there we go. This Bacillophora is a hard coral, but you can see waving in the current. Those are the polyps extending out from its hard, stony skeleton, trying to catch little bits of food as it goes by. You can see the funny shape on this one too, where those branches come up and then sort of curve to the right. And that's because I've got a strong pump over here. Oh, there it is. That's our gyre pump. So we've got many pumps in this tank to move water all about. Corals live by living in shallower water. There's lots of turbulence as currents and tides and waves go crashing over the reefs. And that's what brings lots of the nutrients to corals for them to use to eat, to grow their algae, to have the energy to feed the algae. No, I'm not getting focused here. So you can see that these guys grew up towards the light, and then as the strong current hit them, it started to bend them over a little bit. So there's many things that affect the growth form of corals. They are always growing towards light like plants are, trying to absorb that energy to grow their algae. But then they're also subjected to the currents that they live around. In the ocean, there's tides that go in and out twice a day. And the tides are often a big part of the current in oceans, and waves are as well. Here's a great example of polyps over here. Get you all around. We have this leather coral here. It's toadstool leather. And there, it has lots of polyps extended today. Toadstools are funny. Sometimes they put out lots of polyps, and sometimes they don't put out any polyps. They're kind of finicky corals and do their own thing at times. So there's some of these things, you can see the polyps quite well. A long neck sticking up with little tiny tentacles at the end, and in the center of that is a mouth. So one cool thing about corals is each polyp has the ability to be its own standalone life form, and yet they'll all live together as a colonial life form. So that leather there is one giant coral, but if I were to go in with a knife and cut big chunks of it off, those chunks would continue to live and grow into their own corals. It's a pretty neat life history. Theoretically, you could cut off a little piece of flesh with a single polyp, and that has the potential to live. Usually if a piece of coral that small is broken off, it ends up not surviving. Usually it needs a slightly larger piece to have the energy stores to make it, to grow into a new coral. But they're a neat life form that way too. They really are kind of a mix between an animal and a plant. So that's our coral reef tank. Let me set this camera down and get my cart ready to move you all along. I thought next we would talk about another fun, unique ecosystem. Let's go look at our Cichlid Tank. There are different cichlids found throughout the world. There are cichlids in South America. Those are like the green terrors and the red devils. I think Oscars may come from South America as well. South American cichlids are known to be usually quite aggressive, and as they grow larger, you can usually only have one or just a few in a tank unless the tank's quite large, because they'll begin to fight with each other. There we go. Oh, there goes one of our Venustus swimming by. Let me get my cardboard back to cut down on that glare. We've got big sheets of cardboard that we use to prop up behind our camera to try to keep the glare out so you guys can see the exhibits a little better. So this is our cichlid tank. Many of the cichlids are hiding now. As I've explained in the past, this group of cichlids is fairly young. We just recently got these cichlids. Many African cichlids are less aggressive than their South American counterparts, but often as they grow large, they can become quite aggressive. And it is a fish-eat-fish world. Here I am putting some food in there, see if I can draw some of them out so you guys can get a little better look at them. And I got a few of the fish excited, but didn't bring them out too much. So African cichlids are a neat group of fish. There's the Venustus, that's the giraffe hap. That's a lemon drop darting around back there, that yellow one. This being a new group, I have not memorized all the different types of cichlids I have in here yet. I think that might have been an electric blue hap that darted by a moment ago. African cichlids are really neat because they come from the Great Salt Lakes of Africa in the Rift Valley in eastern and central Africa. There are a number of Great Salt Lakes. There's Lake Tanganyika, Lake Victoria, and this tank is supposed to represent Lake Malawi. And they're called salt lakes because many of them have either no drainage or just very poor drainage, so water flows in and the only way it leaves is through evaporation, or that's primarily the way it leaves. Now you can see them darting all around. Nope. And because very little water flows out and most of the water evaporates, it means that salts get concentrated, because as many of you may know, salt cannot evaporate. Water can, but that's all. And so water evaporates, it leaves behind all the things that were dissolved in it. And so many of these lakes have very high salinity contents. They're not as salty as ocean water for sure, nothing like that, but they're much saltier than most freshwater bodies you'd come across. They're high in alkalinity and salts, and so these fish are accustomed to much different water than most other fish. It's fun watching them dart all around. Oh, there's our favorite Frank. He's one of our tank-bred fish. He had a little fungal infection, but we took him to the back and treated him, and it seems to be all cleared up, so we brought him back out to the exhibit again. But one of the really cool things about these African cichlids is they come from these lakes. They are fairly large lakes. But the really neat thing about them is that there are hundreds of species of cichlids living in them. And then the crazy thing is that in captivity, when we take these different cichlids and put them together, they'll hybridize with one another. They'll breed together, and you'll end up getting hybrids rather than just the pure species they are. And so clearly, they can breed with one another, and yet in the wild, that doesn't happen. And there are hundreds of species in these lakes. And so for a long time, it was really unclear, how can this be happening? How are these fish able, how did this speciation occur? How are there so many different types of fish, but they don't breed together? And there's many different mechanisms people are discovering as to how this happens. Oftentimes it's behavioral, and oftentimes it could be habitat related. The behavioral thing is that some fish will like to live in certain places. They like to just live where there's lots of rocks that they can dart in and out about. And some will live in more open water. Those are usually the larger and more aggressive fish that can be a little safer. And so these cichlids will have different behaviors and where they like to hang out, and different ways that they'll breed with one another. Some like to create little nests on the bottom, and they'll want a rocky bottom, and others don't create those nests. Many of them are mouth brooders, so the males will actually hold eggs in their mouths. And so all these different habitat types and behaviors. There goes Frank again, getting chased about. Yeah, this is him over here. He is a hybrid cichlid. He was produced in our tank, so he is not a fish that you would find in the wild. He is two different species that crossbred together. So we try to just keep natural animals in our tanks. We occasionally keep albinos to show what an albino is. And we keep Frank because we love him so much. He made it into our filter, and that's how he kept from getting gobbled up by the adults. It took us a long time to catch him and get him out of the filter. But we love him. He's a fun fish. I think I distracted myself talking about speciation. Speciation is a really neat concept, a really neat thing to learn about, the way that all these different species can exist. All species generally occupy their own niches and compete with one another. And there are all sorts of mechanisms to keep them separated, even if they can hybridize. That's our Cichlid Tank. I was thinking today at the end of the tour I might try to set you all up on the side of the Cichlid Tank. We have probably won't get to see this, it's a little too dark in here. I'll show you our label down here. In this tank we have one Cynodontis. That's a little too dark there. Yeah, not showing up. I don't have the room lights on. This is a catfish. Malawi Cyno, it's called. This catfish has lived in this tank longer than I've worked here. It's probably been in here, maybe not quite for 8 years now, but getting close on to 8 years. When I started here, my predecessor told me, well, I put a catfish in here, but I haven't seen it in months and months. I think it probably died. And I think I'd worked here for at least 6 months. And one day, as I was feeding the tank, I saw something dart by. I said, what was that? And I took a close look, and it turned out it was the Cyno. There's a cave in the back of this rockwork, and that Cyno, when it was smaller, used to live there. I think there was a hole in the back of the cave where it would go and hide out. But it's grown quite large now, and we're getting to see it much more often. So at the end of the tour, I'll set you all up on the end of the tank here. If I can get it just right, I'll set you up so you'll be able to see the Cyno if it decides to come out. But also you may be able to see the lionfish right through the tank, and if things are just right, you might even be able to see all the way down into the reef tank too. It's fun looking through all the tanks at one time. Well, next, we're going to come over and take a look at our beaded lizard. I got a mouse out. I defrosted a mouse. Here's our lionfish. We'll say a quick hi to them. Today when I tried to feed them, one of them cooperated and ate quite well. That was this guy. This one, I don't know what gender they are. And the other one, this one here, was too busy bickering with its tank mate, and it missed its food. And I tried reaching down into the tank to get it, and it was too excited about me, and I didn't want to get pricked. So this guy hasn't eaten yet. I'll have to get it some more food later in the day. But right behind our lionfish tank is our beaded lizard. There it is, hiding under its cave. That's its favorite place to hang out. I think it likes to keep its head out, sticking out like that. It can absorb some sunshine and some UV rays. Keep its bones strong, stay nice and warm. Keeping its head warm helps its brain work a little better too. They're cold-blooded, so they're always the temperature of their surroundings. So I defrosted a mouse, and we're gonna feed this guy. If you all would prefer not to see this lizard eat a mouse, please stop watching now. Take me just a second here to get this cage open. We just finished out our supply of medium-sized mice. And so now this one is going to get a large mouse. I believe our keeper Emily has fed it a large mouse already, but I haven't gotten to see it eat a large mouse. So I'm excited to see how this goes. Let me get this cage unlocked. Backed up just a little bit. Oh, hitting my hose. Here. There it is. See it flicking its tongue? It can smell some fun smells. My splint on my arm. I haven't been able to shower this past week, so it's probably smelling me. Goodness gracious. I'll get my splint off today and get a brace, so I'll finally be able to shower again and start using my arm a little bit. You can see it flicking its tongue there. As I mentioned, I think in the last tour, these guys have a pretty cool forked tongue like a snake. And they use that tongue, let me get this focused better. They use that tongue to sense their surroundings. It's a smelling smelling apparatus. They flick it out and touch it on things or just wave it in the air. And when they pull it back in their mouth, I'm pretty sure these guys, like snakes, have a Jacobson's organ, it's called. And that's an organ on the top of their mouth that they rub their tongue against. And it's a smell detector. And it tells them all the things that are in their environment. Still having focus issues. There we go. I think that's a little better in focus. Good. Head-on shot there. You can see that forked tongue flicking in and out. So as far as I know, I'm pretty sure all snakes, venomous snakes that is, have their venom glands in the top of their mouths. Oh, Smells the mouse. Here comes the mouse in. Said he. I actually hope this is a she, but I have no idea what gender it is. Trying to get that set up so I don't have to hang on to the camera. This is a venomous lizard. As far as I know, this is the only venomous lizard in Tompkins County that's on exhibit. The only one I know of at all, but there could be others. Just this is the only one that's on exhibit. Look at that. Like a snake, he takes it down in one giant gulp. Just a little bite after a time, kind of squeezing it right down. So these guys, what I was saying is they have their venom glands on their bottom jaw. Totally different and unique from how snakes have their venom. Most snakes, I'm not sure about rear fang snakes, but I know both the lapids and vipers that have the front fangs, they have muscles around their venom glands, so when they bite something and want to envenomate it, they can flex those muscles and squeeze the venom right out of their venom glands through their fangs and into their prey or would-be predator. These guys have very different venom glands. They're in the bottom jaw, and there's a groove along the teeth rather than a hollow tooth like a snake has. Snakes have like hypodermic needles, so it's a hollow tooth that actually the venom flows through the tooth and out the hole in the bottom of it. These guys have groove teeth, and the venom is more like it oozes out of their venom glands and slides along that groove and then gets into their prey or would-be predator. Because of that venom delivery mechanism, it means that they, in order to envenomate something, they have to bite onto it and hang on. So typically when you get bit by one of these guys, they bite and hold on, kind of like a pit bull. They just chomp on and they don't let go, and it can be really hard to get them off. And then it takes time for that venom to slowly ooze along that groove and get into your flesh. Luckily, I don't know anything about getting envenomated by these guys. I hope I never get to learn. But I have heard, I have read and been told that their venom is incredibly painful. It is not as likely, because of that high pain that it causes, it's likely that it's not being used for prey subduction, just subduing prey. It's more likely used to get predators to avoid them. So if a coyote or a coatimundi or some other animal comes and tries to eat a beaded lizard and they get bit by one, they will get hurt and they will remember it. It is unlikely to kill an animal. They probably can kill smaller animals. I don't believe there's ever been a fatality listed from a heloderma, from a Gila monster or a beaded lizard, not in a human. It just causes extreme and excruciating pain. And so once you've been bit by one, you'll always be careful to not get bit by another one. Well, that's our beaded lizard. Only covered the 3 exhibits today, but that's going to be it for our tour. I've got a bunch of water changes to do, and I get to go off to the doctor and get this awful sling off. I'm so excited to get my brace. If I just wait another 6 weeks, I'll be cursing that brace too and be so excited to get out of that thing. Pretty amazing what modern medicine can do. Let me grab this camera, pull it back in. Close up and lock this exhibit right away. Don't need a venomous lizard on the loose. There we go, got that beaded lizard all locked up. It's a really fun lizard. I really enjoyed having it here and getting to keep it. Okay, I'm going to take you all over and try to get you set up looking through all these tanks. Let's see how this works. There you can see my freshwater hose. I was just getting ready to do another water change when the tour time came. Oh! Got you looking at the floor. There we go. We have some really great systems here to make cleaning our exhibits nice and easy. Like this freshwater line. We have special filters in our back room to make the tap water clean and pure for our aquariums and animals. We've got these great hose systems to bring it out to the exhibits. There's our question box. Can't wait till we open back up and you all can come and ask more questions again. On that note, you can always send me questions or comments. My email address is cmeeks, C like Colin, Meeks, M-E-E-K-S, at sciencecenter.org. That Science Center is one melded word. Always happy to show off a particular animal if anyone wants to see it. Talk about any particular topics. There you can see our lionfish in the background. A little hard to make out the reef tank over there, but you can kind of see the reef beyond the lionfish. I'll leave you here. Gotta make a decision whether to let you see the lionfish and the reef or let you see the cyno. The cyno, if it comes out, will likely be down that corner over here, and this is where it usually hangs out. A little dark there. I'll set up our red light so you can even check in at night. You'll see these guys swimming around. Well, thanks again for tuning in. Come back again on next Tuesday, 2 o'clock, and we'll do another tour. Take care.